My name is John Bradley. I'm a solutions architect for Fujitsu. We provide a managed service for the UK Post Office. And what I'll explain to you is the journey that we're on at the minute, from going from a on-premises data center using currently TWS 8.3 and how we move into AWS Cloud using the very latest version of IWS in containers, and I'll go through the architecture, how we're monitoring it, how we're deploying it, and where we're going with our next steps. So it's not just a refactor of the scheduling environment. So as I say, we're going from TWS 8.3 to IWS 9.5 and all of the steps that's required in there, but we're also looking at a review of the batch itself. We are going to we're already taking advantage of using the new folder structure and security that it enables us, and also we're in a position of transition many of the jobs where we've traditionally had to script things and get around things to using native integrations. So I'll talk around this picture for a little while because I think this is the most interesting, and explain to you where we are today. And if I use any terms within AWS, I'll try and explain what they are. So as Franco's explained, we are running containers in EKS, which is the AWS Managed Kubernetes Service. We're running DWCs and master domain managers and a number of agents. We're running a hybrid environment because we're also running dynamic agents on VM EC2 instances outside, and this is because many of the database jobs that we have to run, they are running scripts and they have a very complex nature, which doesn't quite fit inside a containerized world at the minute. So whilst we're deploying this in an agile manner, we're working to enable us to reuse as much of the existing code as we can, with an eye to the future on what we can refactor quickly as part of that transition. We're using, for high availability, for persistent storage, we're using EFS, which is an AWS managed service for NFS file shares. The advantage, and this works quite nicely, is that EFS is visible across all data centers. So for high availability, a combination of using Kubernetes and EFS means that we get a very simple high availability architecture. The database we're using is MS SQL, also as a AWS platform as a service offering. Excuse me. Part of the refactoring that we're doing is moving from on-premises databases, and you can see up there in the top right that we've got those agents, those two boxes, agents 2 and 3 are indicating that we're running via EC2 VMware agents. These are a part of the dynamic pool, and these are running scripts against Aurora, which is a high availability AWS Postgres database, and also against Oracle RDS instances. The scripts, you can see in that green line, the scripts are on EFS, so it does it. We can auto scale the EC2 instances and also makes those highly available to data center outage. We're also using a method of semaphores, because shadow jobs are not an option in TWS 8.3. So during migration, as we need to have cross dependencies between 9.5 and 8.3, we're just using a very simple method of flag file dependencies. I'll just flick on it. So from a monitoring point of view, where the containers expose the data, the logs to Kubernetes, we're using FluentD to collect those logs and send them to Elasticsearch within AWS. I won't go too much into the FluentD option, but if you Google Splunk has an option of using FluentD to send it into Splunk that's well documented, you'll find that solution and see that it's simply a reuse of FluentD in that method, but in method of sending logs to Elasticsearch. Just flicking back, where there are logs that aren't exposed to Kubernetes, TWS merge as an example that's within the master domain manager, that file is visible on the EFS persistent store, and therefore we've got a sidecar container that's running, and that's scraping any other logs that we need from those containers, and they're also ending up in Kubernetes. So at the moment, we're able to get logs from anywhere we want to and aggregate them all together in Elasticsearch. As for deployment, Franco's already gone through Helm charts. We have used the IBM Helm chart. We've modified it very, very minorly. The Helm chart is good to go pretty much off GitHub. We've tweaked it a little bit, but that's what we've used to deploy our environment. It worked really well. For the EC2 instances, we're using Ansible to configure those EC2 instances. And for the database, we extract the scripts from IWS as part of the deployment, and we use an open source product called Liquibase, which enables us then as a fully automated CI/CD pipeline to deploy the whole environment. From a batch side, we're using workload applications to export and import job definitions. So really going forward, next steps, from a monitoring point of view, we are adding Prometheus anyway, and we want to exploit the Prometheus that's exposed in the containers in IWS to enrich the monitoring that we already do. We are using CloudWatch at the minute. That's because as an agile manner, Elasticsearch wasn't stood up in the early stage. It is now, so we will be replacing CloudWatch logs in that monitoring container with file beats, but the main work that we'll be doing in the batch environment is, as we're rehosting applications into public cloud, we want to start refactoring many of the scripts as they come over using IWS native job types instead of maintaining all of the legacy shell scripts that we've built over the years. So that's quite a quick tour, but really it's as vanilla as an IWS install as you can get. The aspiration was that we wouldn't customize or try and do anything fancy. We want to use the IWS application as is, the IBM supplied Helm charts as they are, and then move to native integrated jobs as we go forward. So this is, I hope, is a classic installation and use of IWS as Franco would expect to see. Any questions?
So you've gone from 8.3 on virtual servers or physical servers?
Physical servers, Solaris.
8.3 on physical servers to IWS 9.5 on Kubernetes.
Yeah.
That's
so,
kind of the jump.
On AWS, on public cloud.
On public cloud. So we haven't switched off TWS 8.3. So to be clear, 8.3 is still running. Yep. And 9, yeah, it is a jump. So 8.3 is still running in the Belfast data centers. What's happening is that we're going from an on-premises data center to a public cloud. So what we've currently got is a parallel run of two separate batch scheduling environments. We've still got batch running on 8.3 in a data center. We've now got batch running on an IWS instance in public cloud. So as the new applications are migrated, refactored, and moved over to public cloud, that batch is run on IWS 9.5. The legacy applications are running on 8.3, but through the fact that EFS is just a network file share, we're able to mount a common area of storage that's visible from both on-premises and IWS, and use flag files as cross dependencies, so that when we have to run a batch in IWS based on dependencies that have run in Belfast. We just use flag files for them. A few of them, but it's a simple method of using semaphores to allow 8.3 and 9.5 to run in parallel. So it's not a migration, it's a parallel run.
Yeah, absolutely. So it's a parallel install, parallel run. As the applications migrate to public cloud, the batch is enabled for them. It's there waiting for them.
Spot on. That's it. Yep.
So in terms of timescales from going to the new environment, how long did it take to build this new architecture on cloud?
So there was a bit of a learning curve. I would say we've now stood up this environment in AWS, and to be fair, it's running a light batch, but it is running batch, and that probably took us about 4 months. But that was based on the fact that we used the IBM Helm chart. We didn't have to develop all of that stuff. So about 4 months. This is, as the picture is described, this is all up and running. Granted, it's, you know, don't think that we're running thousands of jobs in AWS yet. We've only got the first application over there now, but it is the fact that it's up, and it wasn't too bad to stand up.
And when you started the official, the charter was not yet official for EKS, so that was built while you was working on this project. That's
right. We did start originally looking in Azure, so that was perhaps a year back. But in AWS, that wasn't official. You're quite correct, Franco. But from the time that the Helm charts, we were able to ditch our own Helm charts and pick yours up, and those are the ones that we've used.
I have a question. You showed that you are extracting the schema from AWS, and you use different products to change the schema of the database. While on the other side, if you just have database, our containers using both DWC and server containers with a credential that allows to modify the schema of the database. When they start, they automatically checks for the schema of the database, and they, in case, if needed, they upgrade the schema. So while you have decided to do that in a separate step, is that because you don't want to grant this a user with so many rights to the containers, or what?
No, that's exactly right. So it is the fact that when we were on premises, it was the case from a release management point of view. They were never comfortable with us automating the update of the database from the products. The DBAs always like to have control of any database upgrades and changes, and we've just carried on with that process. So we make a mindful decision of when we manage and upgrade that database, rather than just let the application do it.
Okay, maybe that we have to simplify that, providing some batch job samples in Kubernetes to use our containers to generate the schema or to upgrade the database as a manual step. Okay.
Sorry, say that again, Franco.
No, I think that this can be done with our containers. So we have the configure DB scripts, so maybe that we can provide in the future some samples on how to use run a job in Kubernetes that, using our images, our official images, can run configure DB, generating the schema or updating the schema in a manual step, so that it can be a standard process more that you don't have to understand by your own.
Yeah.
Okay, does anyone have any questions for John or Franco? If you do, then please put it in the chat window now.
Or don't be shy and just talk. we are still a small community that are used to meet face by face.
Just a general question, actually, for especially for John. If you should tell, well, we all know the advantages of Kubernetes and moving to this kind of architecture we can see in front of us. But if you should just tell the biggest advantage of this new architecture, what you will point out, John?
High availability. The fact that on premises we have to worry about database clusters and how do we deal with the fact that the master's gone away and switching over to backup masters. The fact now that the database is provided, the PaaS solution is out of the box, highly available managed solution. Kubernetes takes care of the fact that if we lose one of the 3 data centers in the AWS Europe West region, who cares? Kubernetes takes care of that, and the persistent storage EFS takes care of that. So from me, the high availability and the recovery, which was always which is always the nightmare when you're trying to provide a highly available business critical application, the assistance that the public cloud gives you is great.
Agreed.
This is a multi-zone deployment of Kubernetes, right? So
yes.
Yeah. John, just wonder what made you choose SQL Server as your database?
It was just cost. We used Oracle in we use Oracle on premises. When we were looking for it, we had a lot of experiences of SQL Server anyway, because for other IBM products that we use on premises, Netcool and BigFix are all using SQL Server backend. So we already had a lot of knowledge around SQL Server. Not so much on Oracle, and so that was the option.
Right, so it was a knowledge thing. DB2 obviously comes with the product, so you chose to go a different way on the basis that you already had the knowledge within the business.
Yes, we didn't use DB2 in 8.3, so it was not that DB2 is an issue. It's just that we had no knowledge of DB2.
Cool, thanks.
Okay, and Mark's got a question as well. So Mark, would you like to unmute and ask your question? Can't do that. Okay.
Yeah, John, Mark was asking if the sidecar was homegrown. Yes.
The sidecar is homegrown. Yes, it is.
So you have modified the Helm chart, adding a new pod that aids the TWS merge.
We've actually written a separate Helm chart, Franco, because we didn't want to. We wanted to leave the IBM IWS implementation as it is. So the sidecar is actually just a separate Helm chart deployment to keep it separate. Okay,
but if you don't mind, you can even, so now that we have the Helm chart on GitHub, you can also fork from that and suggest to remerge your changes. So that can be also an interactive process where all customers contribute with their changes, their customization. We can accept them in the official one.
We'll look at that, particularly as we change to using file beats for EKS. So we'll do that.
Because that can help, for example, in having a single chart, but so making that available to other customers. But at the same time, probably having the same chart simplifies your work on having the sidecar always available where the agent or the server is running.
Yeah.
Okay. If there are no more questions, then it just leaves me to say thank you to Franco and to John for their presentations. Certainly the jump that you've taken, John, is massive from 8.3 to 9.5, and it's fantastic that it's successful and you're ready to go with the applications